Have you ever struggled to categorize something definitively? It's a common experience, and it can be quite perplexing. We often find ourselves in situations where the lines between categories blur, making it difficult to make a clear-cut decision. Take, for example, the humble tomato. Is it a fruit or a vegetable? Botanically, it's a fruit, but in culinary terms, it's often treated as a vegetable. This simple question can spark debates and leave us scratching our heads. Or consider the majestic whale. Is it a fish or a mammal? Despite living in the ocean like fish, whales are mammals, complete with lungs and the need to surface for air. These examples show how nature defies our attempts to neatly categorize it. Sometimes, the world isn't as black and white as we'd like it to be. Our cities, with their diverse populations and complex infrastructures, are perfect examples of this. They are melting pots of cultures, ideas, and lifestyles, making them vibrant, but also challenging to define. That's where fuzzy logic comes in. Fuzzy logic is a revolutionary approach that allows us to handle the gray areas of life. It acknowledges that not everything can be classified in binary terms. Imagine a world where computers can understand and process uncertainty, just like our human brains do. This is not science fiction. It's the reality of fuzzy logic. It enables machines to make decisions based on imprecise information, much like we do every day. This is the world of fuzzy logic, a fascinating field that allows computers to work with concepts that are not entirely true or false, but somewhere in between. It bridges the gap between human intuition and machine precision, creating a synergy that enhances both. Fuzzy logic helps us build smarter systems that can handle the complexities of the real world, where things are rarely absolute. From smart city technologies to automated systems, fuzzy logic is at the heart of innovations that make our lives easier and more efficient. So, buckle up and get ready to explore the fascinating world of fuzzy logic. It's a journey into a realm where the boundaries are fluid and the possibilities are endless. Embrace the uncertainty and discover how fuzzy logic is shaping the future. In the realm of traditional logic, things are either true or false, 1 or 0. There's no in-between. This binary way of thinking has been the foundation of classical computing and decision-making for decades. It's a clear-cut, black-and-white approach that leaves no room for ambiguity. But what about concepts like tall, warm, or fast? These everyday terms don't fit neatly into binary categories. They are inherently subjective and vary based on context and perspective. These are not absolute, but rather exist on a spectrum. Just as colors blend seamlessly into one another, so do many of the attributes we encounter in the real world. This spectrum-based thinking allows for a more nuanced understanding of reality. Fuzzy logic introduces the concept of degrees of truth, allowing for values between 0 and 1. Unlike traditional binary logic, fuzzy logic acknowledges that truth can be partial and that there are shades of gray in between the black and white. For example, a person who is 6 feet tall might be considered tall to a degree of 0.8. This means that while they are not absolutely tall, they are quite close to it. While a person who is 5 feet tall might be considered tall to a degree of 0.5. This person is somewhat tall, but not as much as the 6-footer. This gradation allows for a more flexible and realistic representation of attributes. This ability to represent and manipulate degrees of truth is what makes fuzzy logic so powerful. It provides a framework for dealing with uncertainty and imprecision, which are common in real-world scenarios. It allows us to model complex systems and make decisions based on imprecise or incomplete information. By embracing the gray areas, we can create more adaptable and intelligent systems that better reflect the complexities of the world we live in. In traditional set theory, an element either belongs to a set or it doesn't. A cat belongs to the set of cats, while a dog doesn't. Simple, right? Fuzzy sets, on the other hand, allow for partial membership. Think about the set of fast cars. A car traveling at 100 mph might be considered a member of this set with a high degree of membership. while a car traveling at 50 mph might have a lower degree of membership. This flexibility makes fuzzy sets ideal for representing concepts that are vague or ambiguous, such as comfortable temperature or good credit score. Fuzzy logic is not just a theoretical concept. It has numerous practical applications in various fields, including control systems, robotics, image processing, and artificial intelligence. One of the most well-known applications of fuzzy logic is in control systems. From washing machines and cameras to traffic lights and subway systems, fuzzy logic helps create more efficient and responsive systems. By considering a range of inputs and their degrees of truth, fuzzy logic enables devices to adjust their behavior more smoothly and intelligently. Section 5. Weather forecasting. Predicting the unpredictable with fuzzy logic. Weather forecasting is, well, a complex task that involves analyzing vast amounts of data and dealing with inherent uncertainties. Traditional forecasting methods often struggle to accurately predict weather patterns, especially in regions with rapidly changing conditions. Fuzzy logic comes to the rescue by allowing meteorologists to incorporate linguistic variables, such as cloudy, rainy, and windy, into their models. By assigning degrees of truth to these variables based on sensor data and expert knowledge, fuzzy logic helps improve the accuracy and reliability of weather forecasts. Section 6. Control systems, from appliances to automobiles. Fuzzy logic has revolutionized the way we design and implement control systems. From simple household appliances to complex industrial processes, fuzzy logic helps create more efficient, responsive, and user-friendly systems. For instance, fuzzy logic is used in washing machines to determine the optimal washing cycle based on factors such as load size, fabric type, and dirt level. In automobiles, fuzzy logic helps control the anti-lock braking system, or ABS, and traction control, improving safety and handling. By mimicking human-like reasoning, fuzzy logic enables control systems to adapt to changing conditions and make smoother, more intelligent decisions. Section 7. Fuzzy logic in medicine. Diagnosing and treating with uncertainty. The field of medicine is rife with uncertainty, making it an ideal domain for applying fuzzy logic. Fuzzy logic can assist doctors in diagnosing diseases, predicting patient outcomes, and developing personalized treatment plans. For example, fuzzy logic can be used to analyze medical images, such as X-rays and MRIs, to identify abnormalities and assist in diagnosis. It can also be used to develop decision support systems that provide doctors with recommendations based on patient data and medical knowledge. By embracing uncertainty and providing a framework for reasoning with imprecise information, fuzzy logic has the potential to significantly impact healthcare. Section 8. The future of fuzzy logic, expanding horizons. As technology continues to advance, the applications of fuzzy logic are only going to expand. This innovative approach to problem solving is not just a theoretical concept, but a practical tool that is being integrated into various fields. Engineers and scientists are constantly exploring new ways to harness its potential. With the rise of artificial intelligence and the Internet of Things, or IoT, fuzzy logic is poised to play an even more significant role in our lives. From self-driving cars that navigate complex urban environments to smart homes that adapt to our daily routines, the possibilities are endless. In the medical field, AI-driven software using fuzzy logic can provide more accurate diagnoses and personalized treatment plans. Financial analysts can make better predictions and decisions by incorporating fuzzy logic into their models. Fuzzy logic offers a powerful tool for dealing with the complexities of our increasingly interconnected world. It allows systems to handle imprecise information and make decisions in a way that mimics human reasoning. This capability is crucial in a world where data is abundant, but often ambiguous. By embracing uncertainty and mimicking human-like reasoning, fuzzy logic is paving the way for a future where machines can understand and interact with the world in a more intuitive and intelligent way. Imagine robots that can adapt to new tasks without explicit programming, or AI assistants that can understand and respond to our needs with a level of empathy and understanding. The future of fuzzy logic is not just about making machines smarter, but about creating a more seamless and harmonious interaction between humans and technology. Section 9. Conclusion. Embracing the power of fuzzy logic. Fuzzy logic is a revolutionary concept that challenges the limitations of traditional logic by embracing uncertainty and imprecision. By allowing for degrees of truth and partial set membership, fuzzy logic enables us to model complex systems and make decisions based on incomplete or ambiguous information. From controlling appliances and predicting the weather to diagnosing diseases and driving cars, fuzzy logic has numerous real-world applications that are transforming various industries. As technology continues to advance, fuzzy logic is poised to play an even more significant role in our lives, helping us navigate the complexities of an increasingly interconnected world.